Uh, Hi everyone, I'm Fernanda. I'm from Ecuador and I work as a developer and team lead at Stack Builders. So today's talk will be Don't Break the Contract, Full Stack Tapes AT with TypeScript. So most of us, we are working with TypeScript in any project. We are scaling our application and that's working fantastic. But in reality, we work with several systems, in a system with several services. And that's another kind of problem. You have other issues there. So today I will talk how TypeScript is going to help us with that. So let's start. So in a service-oriented architecture, you usually have services that provide to other components and some service with services. So in this kind of architecture, you have two major roles. That's the provider, and the other one is the consumer. So the consumer sends a request to the provider, and the provider, if you have the authorization or is applicable, will send you the response. So that communication between these two components it relies on something that we call the contract. Okay, so everything works fine if we are following this contract. As in any other field, a contract is basically a set of assertions that says what should we be doing in this communication. Okay, so a fairly common architecture, an example of this is basically you have a server and you have some consumers that might be a web application or a mobile application. And again, in this kind of architecture, we are relying on a contract. We often use RESTful APIs for that communication. So let's continue with our example. So let's see here, we have a data structure. It's a pretty simple one. You have a name that is a string and a price that is, just a value here. So as you know, in software things change quickly. So someone asked us to change that price to a list of prices. So that's important. That's a short change, but it's important. So what happens if you forget to update that in your consumer? If you break that contract, okay? That maybe you are breaking your consumer, you are breaking all your applications. And in theory, this is only a one line change that is breaking everything. So modifying any data structure might lead to this kind of issues. And it's a pretty common one. If you're a full stack developer, I'm pretty sure that you are suffering this. So as I mentioned, this is a fairly common issue. So how do we solve it? Before going with TypeScript and talk about how much we love TypeScript, let's see other solutions. So one of the most common ones is integration tests. So in an integration test, you basically need to set up your provider, and then you need to set up your consumer. So basically you have these two services working, or even if you don't have the two services, at least you have to set up the modules that you need in order to have that communication. So basically you are simulating the communication. You have the request, and then you will have the response. And then you will check that and assert whether it's okay or not. So basically, that's how an integration test is working. You have some modules here. So integration tests are expensive and slow. Why? Because you have two systems. You need to set up two systems. And if you have to do that every time you just submit something, that will be an issue because, setting up two services might be an overhead. And this is slow because you need to write the test for that. And it's not as easy as a simple pure function. Here you have to set up an entire system, you need to create the word, and that's difficult. So that's why it's expensive also to write those tests. But in theory, these tests are really reliable because they are very close to reality. So they are reliable because it's, you know, almost like having your entire system working. Another kind of tests are contract tests. In this case, you set up your provider, but instead of setting up another service, you have something in the middle, and you simulate that communication. You have the request, the response, and you validate that communication against this contract. This contract might be, a file with some assertions. It might be just a data structure. So your test needs to validate that you are using that assertion. With a consumer, it's the same thing. You just set up your consumer. Maybe you even turn down your provider, and you do the same. You simulate the communication, and you are using a contract. That could be a file, or as I mentioned, there are several tools. Depending on that tool, that contract is different. So in theory, contract tests are less expensive, less slow. You don't have to create the entire world to test your application. It's more easy to do that. But at the same time, it's less reliable, because if you forget, think again, you rely on that contract. So if you don't update that contract when you are updating your application, you might have an issue there. So probably your tests are not as reliable as before. So this is where I would like to talk about TypeScript, how TypeScript can help us with this issue. So there is a nice feature, I think Anders just mentioned that early, that's project reference. And with this, we can move TypeScript to a distributed system level. We can have our contracts validated by our type system. So if we think from a directory perspective or module perspective, you will have, for example, a client and a server, and each one is a different module. The client has its own tests, its own types, the same again with the server. So in the server, you might have Node with TypeScript, or you might have Nest that has TypeScript. In the client, you may have React, Angular, or Vue, whatever you want, but you have the types. So each one has its own TSConf JSON. And what we will add here is a shared types module. Basically, in this module, you will define your types that define the contract. So your contract is another module that is, and basically they are. This module is a set of types. So basically, with this kind of configuration, your client will reference your shared types, and your server will refer also to these shared types. And what TypeScript is providing here, and that's the wonderful thing here, is this solution file, the TSConf, that is at the same level as your packages. So what is the good thing about this? Is basically you just have a single command to orchestrate everything. You don't need to go by each package and compiling and everything. No, you just need to run a single command. So this is an example of that solution file, and you just have to define the different leaves of your projects. It's like an entry point. And your client will reference to the shared types. So that's pretty much all the things that you need. If your system is more complex, if you have different if you have different services or providers, you just need to be according this format. So I hope you can see that, but basically this is how you will build your entire project. Maybe if I zoom in, you can see. So the compiler will, it identifying your different components. And if you can use the incremental builds for that. So as we see before, that helps us, in speed. So let's talk about the things that we are improving here. And the first thing that is the main advantage of here is that types are the single source of truth. So there are many solutions for this problem, but most of these solutions depend on the tools that you are using. So if you modify your code, you might need to modify another file in order to have that construct. But with TypeScript, your types are the single source of truth. So here I'm showing you an example of how to define a small construct. So basically, you define the types that you will need in your communication. For example, here, user, and get users. We will see this in more detail. And you will use that, for example, in your server or in your client. So generally, when we are using API, we need to, for example, have a list of something. So here we have a list of users, and it's a function that is within a promise. The result is a list of users within a promise. Why a promise? Because in general, when you are using, a system like this, your function that is calling to get all these users has side effects. And in general, that can be a call for a database or maybe another API. So that's why we have the promise. And then, as we are using the user, we should also define that type. So in users, we have the same function. Again, the types that we are using here are the same that we are using in our contract, in our shared types. So in the server, we just are using that, and we will also use the same user as we have here. So as you can see, you are not repeating code. You are not using other source. You have the types as the single source of truth. So let's imagine that we need to change something here, and I'm going to change the interface. So let's do that, and let's try to compile that. So then when we have this amazing thing of checking whether those types were updated or not, and then we start seeing some errors. In this case, the error that we are seeing here, it's in the client, and I only add the first one because I had a lot. And you can see it's a beautiful error. Thank you. and it's pretty clear what things we need to change in order, to compile our project. So contracts change with types, and the build will fail if the server or the client are different. Another thing that we have here is logical separation between components. So as you can see, you have your client is another package, another package for the server, and another package for your shared types. So those are separate, they are independent. As I mentioned, you can even have tests for each one, and you can have even tests for your shared types for your contract. So we have separation of concerns, we have loosely coupled packages, and no cross-reference code. Everything is dependent, everything is in its domain. Another thing that we have with this kind of setup is package versioning. It might not be that hard here. So for example, let's imagine that you are working in a project with a lot of packages, and you need to write a feature that works with different packages. In this case, a package A and a package B. So you need to start writing your code, writing tests for package A, and maybe after that you need to publish that package. So in order to your changes be in other parts of your code, you need to update that package. So for example, in package B, you will need to update the version of your previous package and then start writing. That's in a good, amazing word, but in general, when you are writing code, you need to go back to the previous package, keep changing the version. So that's difficult. With project reference, you might avoid that. So you just, as all your project depends on a build, or you'd have to build that project, you just write and compile things. So you don't need to keep taking care of the versions or so on. But again, there are some tools that rely on that workflow, so if that's good for you, go ahead. So again, you don't have this need of republishing a package, and you won't need extra tools to handle versions. So with TypeScript, you probably might avoid a lot of tools that can help in the same issue. So if you need just to make things with less overhead, TypeScript is like, now your only solution for a lot of problems. So again, with this, we are seeing that types are a powerful tool for another kind of problems. So you need to take advantage of that. Your types are powerful, and you can do anything with this. So I understand that you might not have Node in your backend. You might have other kind of languages. But if you have some kind of type system in your backend, that might be Haskell or maybe Scala, other languages, there are tools. For example, here I just pick a couple of libraries. In Haskell, you can create types, definitions, from your Haskell data types, and the same thing with Scala. And you will see that there are a lot of languages that are following these steps. For example, Python with time notations, if you are using that, you can use one of these tools. And basically, you are creating the same setup for this. So go ahead, please choose your types. So we go back to the start. TypeScript is becoming a powerful tool not only for a single project. If we start exploring this project reference, we can see that we can ensure many rules. If your projects rely on types for many steps, for many logic, you will delete you will delete that part where you rely on other tools. So basically, you are giving your compiler the ability to assert that your logic or your architecture is working as expected. So this is just an example, but you can do a lot of things with TypeScript. In that sense, I think we can improve the documentation, but again, let's explore. This is just a small overview of how types can go in that way. And I'm pretty sure that in the future we will see more opportunities. So that's it from my side. Thank you. I think you can follow me on Twitter, or if you have some questions, I'll be around. And actually, I was inspired by some of the repos from Ryan, so from the TypeScript team. So that's a good place to start if you want to explore TypeScript project reference. Thank you.